Hi there. Thank you for joining my session. My name is Matt York. I'm a solutions architect working at Red Hat, specifically within the financial services sector. Today, my talk is going to be keeping your ducks in a row with compliance as code. And the purpose behind this is really to make you guys aware of the solutions that we have and the ways that I've been working with my customers in managing compliance as code. So this session, the main topics that we're going to be covering are compliance as code. What is it? We're also going to talk about why it's important to use compliance as code. Hopefully, I'm going to give you some suggestions of tools that you can use to help you on your compliance as code journey, as well as some of the concepts that have helped other customers with successful adoption of it. I'll also share the lessons learned that we've had when we've been working with other customers to actually try and implement this. And finally, we'll give you some notes and things that you can take away to hopefully apply to your own environments. So the first thing I should say is there are lots of ducks in this presentation. I like ducks, therefore there are lots of ducks throughout. If you don't like ducks, now's the time to disconnect. So what is compliance as code? First of all, the purpose behind compliance as code is many of us are doing configuration management across our environments, but actually compliance as code is quite a specific area of this because we need to deal with things such as securing containers, operating systems, applications, container platforms, and actually the end-to-end services. And finally, being able to demonstrate and to prove these to regulators, to security teams, to anyone that asks, effectively. This is particularly important to my customers. As I said, I work in financial services, so we're talking building societies, banks, payments companies. They all need to be compliant, and it's the number one topic for all of them. In terms of using automation, so you can achieve some compliance as code with automation, but actually it's a much bigger topic than that. And we've learned a lot from many of our customers that I'd like to share throughout this, and hopefully you'll find it useful with your customers as we go forward. So again, I talk about financial services, but this applies equally to government, healthcare, and to anything where these mission critical platforms, and in some cases these could be life and death platforms. So it's really, really important that compliance is taken seriously. The regulation itself is getting far more complex. So especially as we're running smaller and smaller components on bigger and bigger platforms, actually multi-tenancy, how we deal with those problems, the penalties have become much more severe. I'm sure we all remember the pain that was GDPR, and actually the significant impact that's had on our industry, and actually the effect of a breach and the reputational damage goes way beyond the individual department that missed a step. Actually, this is forcing senior execs to resign. It causes reputational damage to a company, and it's something that's taken really, really seriously. So if we can do compliance already, why would we bother to do it as code? Well, a big part of that is consistency. So if we are using well-tested, well-executed code throughout the estate, we can actually share that with others, and we can prove that with tests and all of those good things. That gives us the idea that this code is of a particular quality, and that we can actually introduce that into other projects, saving time in those projects, as well as saving the additional checks and building confidence amongst other teams. Collaboration, other teams will use it. We can audit it, storing its code. So suddenly we can see the history of this. So if there's a CIS version 2 or a CIS version 2.2 or 2.3, we can actually see how our own code has changed based on that. We can give that code to somebody else who maybe isn't a domain expert, and we can get them to run our code and to use it. Ideally, we'll have some observability in there. So with code being idempotent, so effectively you can run the same code multiple times and get the same result. That can be used to verify the status of a particular system or service. The remediation can actually be coupled with that observability. And in the same way, automation is a really big part of this. You can actually take those individual code components and build them into perhaps a workflow or a pipeline to ensure that that code is being executed all the time and as part of any checks or validation automation tests that you have. So let me give you an example of one of my customers' environment, actually a couple of customers' environments. So they're running Linux systems, Solaris systems. They're actually running Windows systems. There's actually some AIX in there, and that's on x86. They're running Z, S390. They're running Power systems. And on top of that, the services running on them are a mixture of PCI DSS, CIS, and loads of other different standards that are running, because the service, the data that's being held within those services varies, and so that needs to be managed. We need to have audit trails. If something goes wrong, people want to know why, where, how did it happen. We need to understand the evidencing. So it's not enough to say, yeah, we've run those checks and it's good. It's not good enough to show them your Ansible playbook and to say, yes, we checked this. They want to see in black and white evidence that you have performed a level of diligence that you should have. We know that within environments, you have demilitarized zones. We know that there are disconnected environments. How do we manage all of these different environments? BCP, so business continuity planning. What if I have an entire dark site that is switched off most of the time until there's a failure, then I power it on? How do I make sure that that is compliant as well? By using the same levels of code, we can actually help do that. The different workloads. So I mentioned before, different workloads have different standards, and there are lots of different teams that are involved in this. So you're likely to want to share code or whatever. I've stolen this shamelessly from one of my security expert colleagues in the US, who put together this kind of path to compliance, which I find really, really compelling, and it explains why compliance is hard and the steps that people tend to go through. So the first thing you have to do is, for a particular workload or a particular project, you need to agree on a standard. Now that standard may be PCI DSS, it might be CIS, whatever it happens to be. Once you've agreed on that standard, you then need to look at the controls that that standard implements. So you may decide, if you are using an entirely passwordless system, actually, do you care about the complexity of passwords on that system? Well, the compliance policy says if you use it, you should, but do you need to? And so there will be certain controls that you use and some that you don't, and that's important. Then you need to implement those controls to make sure that's actually implemented into the builds or into the remediation. And then you need to be able to assess those controls and ensure that they've actually been enforced. And that will be your evidence that you give to an auditor or to the security teams. You then need to be able to effectively badge that system, authorize it, and say, yeah, this has gone through. We'll stick the green, the red tractor badge of approval on the side, and off it goes. Finally, we don't forget, when a system goes into production, actually, we need to be able to monitor those controls and make sure that they stay. If I have a CIS compliant system and a new version of the CIS standard comes out, I need to at least know that I'm no longer compliant with the new version, and I need to have a mechanism for being able to bring myself up to that level. So, as you would expect, Red Hat has made our entire organization has been based on bringing open source to the enterprise and making it consumable. So there, a fair while back, there was effectively a way of describing policies, a kind of a protocol, a standard called SCAP, which was it was curated not just by Red Hat, but a group of different organizations that effectively said SCAP is a way that we will define what a policy looks like. And that might be CIS, PCI, and actually Red Hat will curate that policy, and we look at, for example, RHEL. We know what controls would need to be implemented in RHEL in order for SCAP for PCI DSS standard to apply to that. The tool that Red Hat have that we supply with RHEL, for example, to enforce that is called OpenSCAP. OpenSCAP is the implementation. SCAP is the definition. It's the protocol that we're effectively applying. It's included with Red Hat Enterprise Linux and a number of different tools. and you can tailor them. So there is a tool called SCAP Workbench, which lets you effectively pick the components that you want to enforce. You can also, for the predefined curated policies that Red Hat have created, there's a software as a service platform called cloud.redhat.com, and you can actually go through a tick box process in there and generate your tailored profile there as well. So once the report has been run, it's a clear an HTML document that gets generated at the back of it, and it says this control has been implemented and it failed. This control has been implemented but it passed, and it gives a really, literally red, amber, green view as to how your system is complying. One of the nice things about SCAP is because we know how it's been implemented within Red Hat, we can actually provide some remediation steps as well, and those are provided in the form of Ansible playbooks and sometimes shell scripts and different things. I've already touched on this briefly, but a really big part of this is using the Ansible, which is our automation engine. I'll explain a bit more about that in a moment, but Ansible has the ability to be bundled with the SCAP profiles to actually remediate issues. So if my passwords aren't complex enough, I can actually remediate that using Ansible scripts that have been provided by Red Hat. Those playbooks obviously are curated and supported by Red Hat, and that functionality is integrated into kind of Satellite, into I'm going to say cloud.redhat.com because that sort of supersedes Insights, and Ansible Tower as well. So you can actually run it on specific hosts. Again, you can remediate via something like Tower, or you can build that into your own pipeline to actually say, we will remediate all systems at build time. Or actually, you may just want to say, I want to check my systems. Are they compliant? If not, then I wish to run a separate Ansible Tower workflow to notify someone or to take a node out of a load balancer so that it's not taking traffic anymore, whatever. It also gives you the whole auditing and reporting component as well. So this is a topic which I could talk for hours on just on this slide, but primarily there's three components when we talk about actually locking a system down. So there's something called AID, which is the Advanced Intrusion Detection. So for RHEL, you are able to select a group of files, and they become effectively, the state of those files is known. If they change, AID is able to identify that has happened, and you can actually perform actions to either notify or to log that the change has happened, or actually to put the files back. SE Linux, again, super important, because that if a process misbehaves and that process has privileged access, your system is now vulnerable with a privileged process. The only thing between you and that system taking control is SE Linux. And effectively, the way SE Linux works is a process says, I want to use this resource, and SE Linux says, yes, there is a policy that allows you to use this resource. If that resource might be a socket, it might be a file, it might be a file system, it could be anything. Now, if we don't have that enforcing, we are in serious risk of that process doing whatever it wants. SE Linux will deny and flag that to you. And so that as an administrator, again, you can take remediative action, and you can take that out of a load balancer, stop it from taking traffic, treat it as a tainted node, and maybe bring another node into service, whatever. And all of these things can be automated using Ansible. Again, role-based access control, if we're using Ansible to remediate it, we want to be able to control who can actually manage these tasks, because that becomes a privileged way of accessing our systems. So role-based access control, hooking in with your Active Directory or your IDM servers to make sure that you have very tight control and auditing around that as well as credentials. So very quickly, the summary of tools that we use, we'll talk about the Ansible Automation Platform. We used to talk about Ansible Engine. We used to talk about Ansible Tower. They are all components within the Ansible Automation Platform. And the important thing about this is that it's now seen as a joined up group because there is curated content. We provide what we call collections. They are selected groups of Ansible playbooks that might show you how to manage RHEL without you needing to be an expert in how to actually perform the task. Things like if you want to manage your F5 load balancer using Ansible, there is a collection for that. And they're all managed and supported by Red Hat or by third-party vendors. And there's effectively a shop you can go to, not to buy, but to actually just use those. Once you've bought the automation platform, you can consume those. SCAP. So when we talk about SCAP, again, that is the tool that allows you to check or really to check if a system is compliant with an SCAP profile. So is my system compliant with my PCI DSS profile? And generates a report that you can actually version control the report if you wish, or you can give it to auditors or whoever. Cloud.redhat.com. So as I mentioned, it's a software as a service offering from Red Hat. And the point is that it gives you a really good way to view and manage your RHEL estate. It also has some Ansible, the ability to run Ansible on your estate from there, as well as a whole heap of other functionality that lets you manage things like OpenShift clusters. And it's awesome. So you should log on to cloud.redhat.com if you haven't already. And finally, source code. So a core part of this that isn't a Red Hat product is good source code control and good processes around it. So obviously Git tends to be the leader in this area. But all of a sudden you can take the compliance checks that you've written and you can share them with others. They can be modified, they could be branched, people can easily feed back corrections that they feel should be there. And it's a very easy way of making sure that you're collaborating well with others, as well as getting all the auditability and all the version control that you would expect. So one of the things here is when we come to adopt compliance as code, and some of these are lessons learned that we've had from other customers. So when I talk about the bottom-up approach, we talk about the ability for an organization, perhaps the admins, who discover they've seen on a blog post this thing called Ansible, and they start adopting it. They realize they can just run a single command on their system and they can start managing systems and actually start automating large chunks of their job, improving the quality of what they do, speeding up the time it takes, and it's fantastic. As someone who adopted it as a sysadmin, it's fantastic. One of the issues around that is it tends to be quite tactical. So the admin will focus on their tasks that they need to solve. They have their own repository. They work in isolation. And what we'll see across estates is that it tends to spread what I call east to west. So other teams will say, oh, how are you doing that? Oh, we'll do that. And then they go through the same process. They build their own silos that we talk about. There's a lot of trial and error goes on as people develop their own code, so consistency problems, and there is a risk of shadow IT. I mean, someone is effectively automating your environment, and there are no guardrails in place. There is no there's no security oversight, which, as an organization, particularly a financial services organization, is absolutely critical. If we looked at the top-down approach, so where someone like Red Hat and the customer goes to senior execs who are part of a program of work and say, actually, you should be adopting Ansible, and here's why. One of the problems with that is it creates a lot more work up front, and it can be a lot slower to progress to actually get people to adopt Ansible, and there's resistance because nobody likes the boss telling them what to do, and then but you do get things like consistency. So we do suddenly start to see that code is being shared, and we do see that problems are being solved in a more strategic way. So there are some benefits to it, but it tends to take longer to get there. And that's something we've definitely seen. So an approach that I've seen work in the past has been actually doing both. So the guys on the ground, they have a job to do. They need to get stuff automated. They want to automate. So give them what they need to get going. Get them solving their problems. Get them writing code. And at the same time, actually, we need to be talking with those admins and helping to show the senior execs the value there. This is helping you with your business, but we need to start thinking about the controls that get put in place. How do we make sure there's consistency? How do we make sure that the regulator isn't going to come in and give us a nasty surprise by saying, what's this guy doing here? Who's got access to those keys? And that's where tools like Tower can come in with a more strategic approach. The benefits of this are that you get the speed of adoption, you get the speed of solving problems that people have. You get it's not necessarily just coming from top down. Actually, other teams are talking to other teams about it. But also you are able to take a longer term, bigger picture view as to how to do that. If you're in any doubt about this, please speak to your Red Hat contact. We'd be happy to come and help and explain to you guys how you might approach that. Sometimes an organization will say, look, we want to do this ourselves, and that's awesome. So something that we as Red Hat have found works really, really well is to build an in-house community practice. What I mean by this is as a group of like-minded individuals who are who are interested, who are excited by what Ansible and SCAP bring, and actually start developing their own developing their own kind of groups, their own chat rooms, whatever it is, and having regular meetings to talk about what they're doing, sharing their ideas, sharing how they're solving problems. In one of my customers, we have a fortnightly wiki call that goes on. It started off where Red Hat ran that session for them, but actually the real key adopters within the organization have taken over. They run that session, and actually Red Hat turn up, but I don't usually say anything unless someone has a question or something they want to raise specifically to me. The organization run it themselves, and you have DevOps teams talking to security teams, answering their questions. It is fantastic, and it has really, really helped the organization speed up the way that they do things. Hackathons. Hackathons are awesome. So actually, if you all have the same problem to solve, then everyone getting together in a room with beer and pizza and trying to solve it's a really good way of doing it, and it's fun. So that's definitely to be encouraged. Red Hat provides you a whole heap of material. So actually on the Ansible open source repository, there are some workshops there that provide labs, presentations, exercises, a whole heap of different material that you can run within your organization to help people adopt that and to make use of Ansible. Failing that, you can always Red Hat run loads of these workshops, so you can always sign up for those as well, and we'd be happy to talk to you about those as well. Some more lessons learned. So where do you start? RHEL 8 got released a little while ago, and the introduction of a new major operating system is a really good place to start, because the first thing you do when you bring a new major operating system is, how do we make it compliant with our current rules and regulations? There are lots more tools that are being built into RHEL as we move forward. For example, I believe it was 8.2, RHEL 8.2 that ships with the CIS standard as default. So all of a sudden, you can make your systems compliant out of the box. So you don't need to engineer that. And we've seen this with customers that are trying to, I talk about abstraction, but when they're trying to build the same version of RHEL for Z, for x86, or for Power, there is a standard place to start from. So make use of that. So a new major operating system is a great time to start thinking about that. Don't just try and do it with an engineering head on. Engineering is super important, but having the architectural feedback as to how you can how this can strategically be applied across the organization is really, really important. And actually, what will this look like in 2 or 3 years' time? And Red Hat will provide roadmaps and things to help your teams build those roadmaps out. Create a user group, run workshops. Everyone, certainly in Red Hat, and I've seen other organizations as well, is people love to be a subject matter expert. This is a great chance for those people to really, get involved in something exciting, and it's a great skill to have. Use what you've already got. Red Hat have put a massive amount of work into developing the SCAP profiles. We've got loads of Ansible playbooks to remediate. Make use of that. It's all part of the Red Hat service, and you should absolutely be taking what we've done and making good use of it. And finally, the first time you do it, it's going to look a bit clunky. That's okay. Just go around the loop again. It's iterative. You will develop, no matter, even if you got it perfect first time, the policies will change. The regulations within your organization will change. So understand that this it will never be finished. It's a process that you are going to have to go around time and time again, but it will get easier. And once you've done it, you will spend much more time running a business rather than trying to develop code. I haven't talked about containers here much. There's a good reason for that. The containers, so the OpenShift platform is, again, I treat it as the same as I would with RHEL or with RHEL on Z, or whether it was RHEL on x86. OpenShift is another platform. It has to be made compliant and it needs to be secured, and all of the things I talked about previously, they all apply to OpenShift. So whether we're talking about applying SCAP profiles, SCAP can be used with OpenShift. There's actually a compliance operator that's being written. So I know that my colleagues in the US have been talking to me about this, that we have a compliance operator that's going to be able to remediate and to look at what you're doing and to give you these same reports. The same would be for the security guide. So there's a book has been produced, which you can, I believe, is freely available for download, and is actually going into there may be a print version as well, where you're able to use there's a kind of storage compliance policy as well. So which actually uses the same aid technology under the hood to make sure that files remain compliant. Excuse me. Again, this was shamelessly stolen from my colleague, but there is an OpenShift security guide. I will share the link as part of these anyway, but it's available to our customers via the portal, and we're working on the ability for this to be made available without having to go through the portal. There's also a print-on-demand option coming as well. So all of these concepts will be available. So just a final summary as we run into the last couple of minutes. Compliance as code tooling, it's part of everything that Red Hat do. Being able to have these tools built in, security is always forefront in our mind, and giving you the tools to make that less of a problem for you to overcome is absolutely something that we want to do. We want you to spend your time focusing on how you drag these components together, how you use them to build what your organization needs for compliance. It will be different for every organization, but with those basic components, you can use it to develop your own compliance as code solution that you can really use to save time and to save effort. Finally, if you've got concerns, you don't have the ability or you don't have the time to do this, Red Hat Professional Services teams, we can help with consultancy, architecture to help deliver that. And finally, there's some references that we'll supply as part of this that get you started and show you where to give you some other reference material to go deep dive in on each of the topics. So with that, I'd like to thank you all for your time. I hope that you are able to use some of this and it's useful, and look forward to seeing you soon. Thank you.